Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating article about how large language models, or LLMs, understand nullability in code. It's a surprisingly complex topic.
Nullability. Can you explain what that is for our listeners?
Absolutely. In programming, nullability refers to whether a variable can have a null value, meaning it doesn't point to any valid data. Think of it like an empty box. It's a box, but it doesn't contain anything.
Okay, I get the empty box analogy. So why is it important for LLMs to understand this?
Because if an LLM doesn't understand nullability, it can write code that crashes or produces unexpected results. Imagine it tries to open that empty box and expects to find something inside. That's a recipe for disaster.
Makes sense. So how do we even begin to figure out if an LLM understands something like that?
Well, the article discusses two main approaches, external and internal measurements. The external approach is pretty straightforward. You give the LLM a code snippet with nullable variables and see if it can complete the code correctly.
Like, does it automatically add checks for run in Python, for example?
Exactly. The article gives a great example. If you have a function that takes an optional integer as input, the LLM should ideally insert a NaReen check before doing anything with that integer.
I see. So it's like testing its ability to write safe code.
Precisely. But the article also points out that variable names and type annotations play a huge role here. If you use descriptive variable names and provide clear type hints, the LLM is much more likely to get it right.
That makes sense. It's like giving the LLM better instructions.
Right. Now, the internal measurement is where things get really interesting. This involves probing the model's internal thoughts to see if it knows whether a variable is nullable, even if it doesn't explicitly show it in the code completion.
Whoa, how do you even do that? Sounds like mind reading.
It's kind of like that. LLMs are based on neural networks, and these networks have layers of activations that represent the model's internal state. By analyzing these activations, we can try to decode what the model is thinking about.
Okay, so you're looking at the numbers inside the machine to see if they light up when it encounters a nullable variable?
That's a great way to put it. The authors built something called a nullability probe, which is essentially a tool that tries to predict whether the model thinks a variable is nullable based on its activations.
And how accurate is this probe? Does it really tell us what the LLM is thinking?
Well, it's not perfect, but it gives us some valuable insights. The authors found that LLMs do indeed have an internal concept of nullability, even if they don't always use it correctly in their code completions.
Interesting. So the LLM knows about nullability, but it sometimes forgets to apply that knowledge?
Something like that. The article also found that the model's understanding of nullability improves with training. The longer you train the model, the better it gets at recognizing and handling nullable variables.
That's reassuring. So these models are actually learning something.
Definitely. And larger models tend to learn faster and achieve better performance overall. However, the authors also noticed that for smaller models, the performance can actually decrease after a certain point in training.
Why is that?
The authors speculate that it might be because the model starts to overfit on the training data, or develops more complex, nonlinear representations that the probe can't capture as well.
So it's like the model is becoming too specialized and losing its general understanding.
Exactly. The article also highlights some limitations. For example, models struggle with interprocedural analysis, which means reasoning about nullability across multiple functions.
So if a variable is passed through several functions, the LLM might lose track of whether it's nullable or not?
That's the idea. And they also found that models have a harder time generating type annotations than simply reasoning about them.
That's not too surprising, since a lot of Python code doesn't use type annotations anyway.
Right. So what's the big takeaway here?
Well, it seems like LLMs are making progress in understanding nullability, but there's still room for improvement. And by probing their internal states, we can get a better sense of what they know and where they're struggling.
Couldn't have said it better myself. The authors are planning to explore how LLMs understand other programming concepts as well, which should be really interesting.
Definitely. It's fascinating to see how these models are learning to reason about code.
It is. And that's all the time we have for today. Thanks for tuning in to Tech Bytes and News. We hope you found this discussion insightful. Join us next time for more tech news and analysis. Goodbye.
Bye-bye.